Once again, you're welcome to Waidsum Academy. Today we'll be looking at mensuration part 2. We've looked at part 1 before. In part 1, we looked at the cylinder and the total surface area of a cylinder and the volume of a cylinder. We also looked at the cuboid and a cube. We did the total surface area of a cuboid and the volume of a cuboid. We did the total surface area of a cube and the volume of a cube. So these are the 3 parts of mensuration we looked at in our previous part 1 video. Today we'll be looking at part 2. Here our topic is prism. We have different types of prism. We have about like 4 or 5 types of prism, but we're going to start with the first one called the rectangular prism. Now if you take a look at this is called a rectangular prism. Why? Because the base area is a rectangle. The base of the prism is a rectangle. So if I choose it as my base, if we decide to choose this place as the base, then it's a rectangle. The base is a rectangle. Whichever we choose as the base, it's a rectangle. Probably here, it's a rectangle. So we call it a rectangular prism. We call it what? A rectangular prism. Why? Because the base is a rectangle. Okay, so it's a type of prism. So, and the popular name for a rectangular prism is a cuboid. The popular name for a rectangular prism is a cuboid. Okay, there's another type of prism. I didn't bother to draw it here, or we didn't bother to put it here. It's called the square prism. The base is a square. So when you have a cube, it's called a square prism. It's called what? A square prism. We can call that number 2, even if we did put the diagram here. Okay. Number 3, we have a circular prism called a cylinder. The base is the area, this cross-sectional area is a circle. The cross-sectional area is a circle. That's why we call it a circular prism. And a good example of a circular prism, in other words, is a cylinder. Like a drum, like a pipe, like oil pipes, and so on and so forth. The third one, the fourth type of prism is a triangular prism. You can see the cross-section is a triangle. The cross-section is a triangle. This type of prism or shapes that have one unique section as a triangle is called a triangular prism. We even have another type of prism, number 5 type of prism is the like a pyramid. Okay, like a pyramid. We have hexagonal prism. If you draw a hexagon like this kind of shape, like cylinder, but this base is a hexagon. If the base shape is a hexagon, like you have something like this as the base, it's called a hexagonal prism. Okay, so we have different type of prism. Okay, we have different type of prism. If you have this base as a hexagon, this base shape as a hexagon, then we say the object is a hexagonal prism. And then you draw it down. You draw it down to meet the next hexagon. You draw it down to meet the next hexagonal head. Okay, the next head at the bottom is same as hexagon. So that type of prism is a hexagonal prism. It's called a hexagonal prism. So we have different types of prism. We have so many different types of prism. But today we're going to look at a few examples. We're going to do some few calculation, and then we'll be good to go. We're going to do some few calculation, and then we'll be good to go. Because today's class is on prism as a type of mensuration. Our next part 3 will be on circular or circles, arc lengths, area of sectors, and so on and so forth type of mensuration. That's the part we're going to look at part 3. But in part 2, now the first question here is a calculate the volume of this cylinder. The question can say calculate the volume of this circular prism. So I can put in brackets circular prism. We can say calculate the volume of this circular prism. The volume of this circular prism. Circular prism. Okay, so they might use the term cylinder or they use the term circular prism. So whichever they use, you should know it's the same thing. You should know it's the same thing, circular prism. You should know it's the same thing. When they give you and they ask you to calculate the volume of this circular prism, you should know that a circular prism is same as a cylinder. Same as what? A cylinder. And we should know the formula for calculating the volume. In part 1, we talked about cylinder, and we put out the formula for calculating cylinder, right? So the formula for volume of a cylinder or circular prism is pi r square. Is pi r square h. Pi r square is the area, you know, right? Area of the circular part is the pi r square. We all know this. The area of the circular part, this circular part, the area is the pi r square. You know, area times length is the volume. When you say A times L or times H, whatever you want to call it, if it's vertical, you can call it H. So pi r square H or pi r square L is the volume, okay? This is the height, and this is the radius. The 4 centimeter is the radius. So to calculate the volume of this cylinder is simply to substitute the values into this formula. Simply to substitute the values into the formula, which is pi. We can choose the volume, the value of pi to be 3.14. 3.14. Then multiply by the radius. Multiply by the radius. The radius in this case, the radius of the circular part is what? 4 centimeters. 4 centimeters. So we're going to say multiply by 4 square. Because from the formula it's a r square. So we're going to square the radius. 4 square, which is 16. 4 square does not mean 8. 4 times 4 is 16. Then multiply by the height of the cylinder. This is the height. Multiply by the height of the cylinder. This is the height of the cylinder, 10 centimeters. Okay, this is the height, or the length. Okay, call it the length. Okay, multiply by 10. So we key this into our work. Here is 16. Okay, multiply by 3.14, multiply by 10. Then we will get 503 if we change the answer to this 3 significant figure. So we get V to be equal to 503. If we round the answer to the nearest 3 significant figure, 503, okay, in the nearest 3 significant figure. If you do your calculation, 3 significant figure. To put our answer in 3 significant figure, we get 503. So we put the unit, you know, you have to put the unit. Since volume, we're looking for volume, and the single unit is centimeter, so this will be centimeter cube. This will be centimeter cube, or cubic centimeter. So we put the unit here, 503 centimeter cube. Okay, this is the volume of this cylinder. This is the volume of this cylinder. Now let's go to the next question. The next question says, calculate the volume of the L-shape. The next question says, calculate the volume of the L-shape prism. Calculate the volume of the L-shape prism. So we're going to find the volume of this L-shaped prism. See? So we have a prism, another type of prism. So prism, it comes in different shapes. You see? This looks like a staircase or whatever you want to call it, like a chair for sitting down. A chair for sitting down sometimes looks like an L shape. If you take out the legs, looks like an L shape. Okay, like anything that is perpendicular is an L shape. That's perpendicular, horizontal and vertical. So if you look at this box, we have an L-shaped box. Now they are asking us to calculate the volume. We cannot calculate the volume of this if we don't significantly find the area of the cross-sectional. We don't find the cross-sectional area of the prism. So we have to identify our cross-sectional area, the base of the prism, of this type of prism. And then since it's an L shape, they call it an L shape, we're going to take the L as the cross-sectional area. So this is going to be our cross-sectional area. This is going to be our cross-sectional area. This way and this way. Okay? This is going to be our cross-sectional because they say L shape. So it has to be an L shape. It has to be an L shape. So if you look at this, we have it 2 rectangles. We can break this L shape into 2 rectangles. Yeah. We can break this L shape into 2 rectangles. Right? We can break this L shape into 2 rectangles. So we can call here A, rectangle A, and we can call here rectangle B. So we have to find the area of each of these rectangles. This L shape, we break it to two rectangles. So we have to find the area of each of the rectangle, and then we add them together, we get the total area of the L shape dimension. And after that, we multiply the area with the length, this long length, this one. We multiply the area with the length. Once we do that, we'll get the volume. We get the volume of the L-shaped prism. So now let's look for the first part. The first part, area A. So we say we find area A. Area of the rectangle A. So when I say area A, I'm saying area of this rectangle A. Area of rectangle A. So I draw a small rectangle to denote that. Rectangle A. Will be equal to what? Let's find the area of rectangle A first. Now, to find the area of rectangle A, we have to find the length and the width. The width is 2, because here is 2 centimeters, so here should be 2 centimeters. Here is 2 centimeters, this place, for rectangle A. Here is 2 centimeters, and here, the whole thing is 6 centimeters. And we cut it from here. Since we cut it from here, we find out what we cut off. The amount we cut off and what will be remaining from here to here. We find out what will be remaining from here to this place. What remains. So we cut off, here is 1, here will also be 1. And therefore, here that you cut off is 1. So what remains is 5. So let's use a different, more conspicuous color. So here will be 5. This place will be 5 centimeters. Remaining will be 5 centimeters. So if here is 5 centimeters, here is 5 centimeters up to this place, 5 centimeters, okay? And here is 2 centimeters. We can find the area of this rectangle. So here is 2, and here is 5. Okay, we can make it vertical, probably. Let's make this one vertical to show the way it looks on the diagram. Okay, to show the way it looks on the diagram. So let's do this. We make the triangle vertical to make it look like the way it looks on the diagram. So here is 2 centimeters. Here is 2 centimeters. Okay, we may skip writing the centimeter. We already know they are in centimeter. We write 2 and 5. Here is 5. Here is 5, and here is 2. That's what we brought out here. So to find the area is length times width. Area is length times width. So what we do, we just say the length is the long one, which is 5, multiplied by the width, which is 2. Multiplied by the width, which is 2. So 5 times 2 is 10, right? So we get the area of A, of this A side, to be 10 centimeters square. 10 centimeters square. To be 10 centimeters square. Okay? Now let's find the area of the B, triangle B. Okay, good. Okay, area of triangle B. Area of triangle B. Look at the way triangle B looks. Look at it this way from the diagram. Here is 1. Okay, let's change the color to make more sense. Here is 1 centimeter, and here is 5. Here is 1, which is this one, which is this one. Here is 1, and this one is 5. So here is 5. So the area of triangle B is equal to length times width as usual. Just we write the formula just to show that we know what we are doing. We will not copy anyone in the exam. Okay, once you write formula, you're telling the examiner that you know what you're doing. You know it. You're not writing from someone else. Okay, so it's 5 times 1. 5 times 1, which is 5, right? Area of this one is 5 times 1. So answer equal to 5. Answer equal to 5. 5 centimeters square. So we now find the total area of the L shape. The first one is 10, the second one is 5. You add them together. So you say total area of L shape. Total area, because you have to get the total area of the L shape before you can calculate the volume. Total area total area of L shape. Total area of L shape will be what? 10 centimeters square plus 5 centimeters square. That means area A plus area B, right? A total. So if I write A total L shape, A total for my L shape will be 10 centimeter, which is for area A. So I can say area A plus area B. Area A plus area B. Area A plus area B. Remember, we broke the L shape into A and B. So area A was 10 centimeters square. So I just write 10 plus 5. We put the centimeter square in the final answer. Plus 5, which is equal to 15 centimeters square. 15 centimeters square. Remember, we're dealing with area, so we put centimeters square. Say 50 centimeters square. So that's the total area of this L shape. Okay? In this type of prism, you have to find the cross-sectional area of, in this case, it's an L shape. After you found the area, the next thing to do is to multiply by the length, or yes, the long length of the prism. To multiply by the long length of the prism. So in order to get the volume. So volume, once you get the total surface area, the volume will be the length. Volume of the prism will be the length, the total surface area times the length. So for volume, so if the question is asking you for the cross-sectional area of the L-shaped prism, you just stop here. You stop here, right? Now for volume, we proceed a little bit for volume. So for volume, let's change our characteristic color. So for volume, V is equal to the cross-sectional area of the L shape, area of the L shape multiplied by the length, Area of the L shape, your cross-sectional area or your base area multiplied by the L. Any type of prism, just find the base area and then multiply by the length or multiply by the height, as the case may be. Any type of prism, this is how to calculate the volume of prism. First of all, identify the cross-section. If the prism is a circular prism, calculate the area of the circle and then multiply by the height or the length, depends. Okay? So that's it, you get the volume. So volume in this regard is equal to 15. Remember, we calculated the total surface area of the L shape. 15 multiplied by, what's the length of the prism? What's the length of the prism? 5 centimeters. The length of the prism is 5 centimeters. Look at it. The length of the prism is 5 centimeters. So we will multiply this 5 centimeters, multiply by the area we got here. You know the area we got here from this cross section? The area of this cross section multiplied by this length, you get the volume of the prism. You get the volume of the prism. So we say multiply by 5. Okay. The volume is equals to 15 times 5. So 15 times 5 we get what? 75, right? We get 75 centimeter cube. We get 75 centimeter cube as the volume of the prism. Okay, so this is how to apply or how to calculate the volume of any prism. Any prism they gave you, don't be scared. All you need to do is to look for the cross-sectional area. Pay attention to the question and find the cross-sectional area. Now, if the cross-sectional area is like a hexagonal, the big question is, how do we find the area of the hexagon? For example, like this one I was showing. How do we find the area of the hexagon? That would be a big question, right? It's not a big thing. It's not a big thing. If you have a hexagon, for example, if you have a prism that looks like this, let's say you have a prism that looks like this, we just give you a hint. Okay, we give a hint, and then we will move on. If you have a prism that looks like this one, If you have a prism that looks like this is hexagon, right? This is 1, 2, 3. It's not perfect, right? We should especially this place. We do it proper. Okay, let's see the shape proper. Let's look for let's look for a hexagon. Let's look for a hexagon and then or let's draw a hexagon. Let's have this hexagon. Okay, this is hexagon, right? Okay, if you give you this as the base, we are giving this hexagon as a base, and then we are to have it as a prism. You know, we have hexagonal prism. Like I said, a prism will come in different shape. Okay, prism will come in different shape. Prism will come in different shape. Prism will come in different shape. Okay, at least you see what we are doing, right? We are just trying to show the hexagonal prism. So when you have a hexagonal prism, when we have a hexagonal prism, then they can ask you to calculate the volume of this hexagonal prism. So it's easy. The only thing I want to show is that we have to calculate the surface area or the cross-sectional area of the hexagonal prism. Right? We have to calculate the area, the cross-sectional area of the hexagonal prism. Okay? So never mind our drawing. Anyway, what we are saying is that if you give you something like this as a hexagonal prism, all you need to do is to find the surfaces. They will tell you the height from here to here. You'll be given the height. Okay? You'll be given the height from here to here. You'll be given the height. And let's say the height is 3.5 centimeter. You know, this is like a triangle now. Okay, and then we from the center from here to here is 4 centimeter. 4 centimeter. So you give you these two parameters, and then you give it this long length. The long length, which is 20 centimeter. 20 centimeter. That will help you eventually to calculate the volume. Okay, this long length, which is 20 centimeter, that eventually helps you to calculate the volume. Now they say calculate the volume of this question number 3. Calculate the volume of this hexagonal prism. Calculate the volume. Calculate the volume of this hexagonal prism. So can we take a look at this? Calculate the volume. The volume of the hexagonal prism. Hexagonal prism. Calculate the volume of the hexagonal prism. Calculate the volume of this hexagonal prism. So what we need to do is to find the area of this base area, this one. Now to do that is to count how many triangles do we have. We calculate the area of one triangle multiplied by how many triangles that can come from here. 1, 2, 3, 4, 5, 6. We can have 6 triangles, right? If we join here to here, for example, right? We can make about 6 triangles from here. 3 on top, 3 at the bottom. See, triangles. Right? Same here. Same goes here. How many triangles? See, 6 triangles. 1, 2, 3, 4, 5, 6. So all I need to do to find the base area is to find the area of a triangle and then multiply by 6, right? Because there are 6 triangles to get the area of the whole hexagon. Get the area of the whole hexagon is to find the area of one triangle. We know the height to be 3.5 centimeter because they've given us this height to be 3.5 centimeter. They've given us the height to be 3.5 centimeter, and they've given us the base of the triangle to be 4 centimeters. So all I need to do, there are 6 triangles in the hexagon. In this regard, there are 6 triangles in this hexagon. So all we need to do is to find the total surface area. So it's to find the base area or the cross-sectional area of cross-section, Once you get the area of the cross-section, then you can find that. Now, one is a triangle. So I'm going to use the formula of a triangle, half base times height, right? This is the height, this is the base. This is the height, this is the base. So area is equals to half of a triangle, half times the base times the height. This is the formula for area of a triangle. This is the formula for area of the triangle. So I'm going to do for only one and then multiply by 6 because they are all equal. They are all equal. They are all same. All of them. So you do for one, you multiply by 6, you get the area of the whole hexagon. You get the area of the whole base or cross-sectional hexagon. So what we do is simply to say this is equal to area is simply equal to area is simply equal to half times the base. The base is 4. You see the base, right? This base is 4. Half times 4. Half times 4 times 3.5. Times 3.5. Because the height is 3.5. The height of the one triangle is 3.5. Look at it. It's 3.5, the height, the vertical height. So on that note, half of 4 is 2. 2 times 3.5 we get 7. So area of one of the triangle is 7 centimeters squared. So to get for 6, 7 centimeters squared. To get for the total surface area or the total cross-sectional area cross-section, area of the whole cross-section, or the base area, the total base area cross-section, or area of the base area is equal to, because there are 6 triangles that makes up the hexagon, you say 6 times 7. 6 times 7, we get 42, right? 6 times 7. So this prism, they can give you any type of prism in the exam. 6 times 7, you get 42. Now the question does not just want you to find the area or the total surface area of the prism, but the question wants you to calculate the volume of the prism. So for us to do the volume of the prism, of this hexagonal prism, the volume of this hexagonal prism is simply the cross-sectional area of the hexagon area of hexagon, base hexagon, area of hexagon, area hexagon, area of the hexagonal base surface times the length, the long length, times the length, times the length. That's how to get the volume. That's how to get the volume times the long length. Okay, so what that says is V equals to the area of the cross hexagonal area, we got 42. We got 42. So 42 centimeters square multiplied by the length. Take the length of the hexagonal shape was 20 centimeters. So you say multiply by 20. 42 multiplied by 20. So if you don't need to use calculator. Just say 2 times 42, you get 84. Then you add a 0. So to do that, you don't need it's not everything you need a calculator for. To be faster in the exam, you should know how to use your brain most times. So 2 times 42, you get 84. Then you add this 0 to it. You get 840 centimeter cube. Because you're looking for volume, you must put the right unit. You don't put the right unit, you lose marks, or even you lose everything. So this is the volume. This is the volume of the triangular prism, of the hexagonal prism. This is the volume of the hexagonal prism. This is the volume of the hexagonal prism, as the case was. So today's part 2, we looked at the prism. We looked at only prism because we looked at circular prism, which is called cylinder. We looked at L-shaped prism, which you can call rectangular prism, or you can call rectangular prism. And then we looked at triangular prism. And then now we looked at both triangular and hexagonal, because the hexagon led us to calculating the area of triangles first. So you can say we looked at everything in prism we've looked at today. Our next class will be looking at the circular part, which is the arc length, the area of sector, and so on and so forth.